Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at repeated percentage increase and decrease. So we use this formula here. A is the amount, P is what you started with, R is the percentage, and N the number of periods. I know it probably doesn't make a lot of sense now, so let's look at an example. So population of a town increasing by 1% each year, currently 100,000. What will be its population in 30 years' time? So it's not actually going to go up by 30%. See, what's happening is, so year one, the population's going to go up by 1%, so it's going to go up to 101,000. But in year two, it's going to go up by 1% of this larger number. So 1% of this is 1,010. So it'll go up to 102,010. Similarly, in year three, it's going to be 10% of this number, not 10% of the original. So the population's actually increasing at an increasing rate. The jump in population between each year is itself increasing. So how are we going to figure out the population after 30 years' time? Well, it would be completely impractical to write all of these years out to 30th year. There must be a quicker way. Well, luckily, there is. See, this is the population after 1 year. It's what you started with, 100,000, and we're just going to increase that by 1%. So that's the same as timesing by 1 plus 1 over 100. So this here is the population after year one. What's the population after year two? Well, year two, I just take the population after year one and increase that by 1%. Okay, so that's the same as multiplying by 1 plus 1 over 100. Of course, a quicker way I could write this in my calculator is 100,000 times 1 plus 1 over 100 squared, because that times itself is that squared. And of course I can do that by the associative law of multiplication, because I can put the brackets anywhere I want in a long string of multiplication. So that's what it would be after year two, and you can probably see the pattern. At the end of year 30, it's going to be the original, and it is going to have had 30 increases of 1%. So we write that as 1 plus 1 over 100 to the power of 30. So putting that on our calculator, we get about 134,785. That's to the nearest whole number. So note here, it's gone up by more than 30%. All right, let's now look at another example. So the value of a car has been decreasing by 5% each year. If it is now worth $20,000, calculate its value 10 years ago. So we're looking for the original. We're looking for what we started with, had percentages applied to it, and ended up at $20,000. So we're going to use a similar formula to the one on the previous slide, but because this involves decreasing, instead of being 1 plus R over 100, it's going to be 1 minus R over 100. Okay, so in this question, A is the amount it's currently worth is 20,000. So I'm going to rub out A, replace it with 20,000. Now P is the original amount. That's what I don't know. That's what we're trying to find. P is whatever number I started with, then took 5% away each year to end up with 20,000. That's why we're finding the original. Okay, so R is always the percentage. So in this case, R is 5 because it was 5%. N is the number of periods. So if it's been decreasing each year for 10 years, there have been 10 periods of decrease. It has been decreased by 5% 10 times. So of course, this here is just a number. It's not a very nice number, but it's a number nonetheless. So if I want P by itself, I just divide 20,000 by that. So this is why I said when you're finding the original, you divide. You end up dividing. So if we put this straight on our calculator, we get about $33,404. So that's just to the nearest whole number. So if you start with this number and you decrease it by 5% of its value 10 times, you'll end up with 20,000. All right, let's look at a harder question. So by what percentage must the value of my investment increase each year if I want it to triple in value in 25 years' time? So here we're finding the percentage, we're finding R. So because the question's talking about increasing, our formula will be A equals P1 plus R over 100 to the power of N. Okay, all we're going to do now is substitute in everything we know and rearrange for what we don't know. So we want to know what it has to increase by each year for 25 years. So N's going to be 25. There are going to be 25 periods. Okay, now we want to find what R is. So we need a bit more information about A and P. But we're told that the value of the investment is to triple. So if we want it to triple, we want A, the amount, to be 3p. We want the amount it's worth to be 3 times the original. It doesn't actually matter whether we start at $1 and end up with $3, or we start at $5,000, end up at $15,000. It doesn't matter. All we want to make sure is that this number is triple that number there. So I'm going to substitute A for 3p. So if I substitute A for 3p, I get this. So because there's a p on both sides here, I can divide each side by p. So dividing each side by p means I'm left with this equation here. 3 equals 1 plus R over 100 to the power of 25. So now I'm just going to perform some algebra to find what R is. So R's been divided by 100, then 1 is added, then raised to the power of 25. How are we going to undo that? Well, the way you undo raising to the power of 25 is actually the 25th root. So taking the 25th root of both sides, I end up with this. So now what we're going to have to do is take our 25th root of 3, and we're going to subtract 1 to get rid of this one here. And then to undo dividing 100, we're going to times each side by 100. So I'm going to take this and times by 100. That will give me R. This is a weird looking thing, but you can put it on your calculator just like that. So if you put this straight on your calculator, you get about 4.49. We know that R is a percent, so what that means is the investment is going to need to increase by about 4.5% each year for 25 years in order to triple. Now note again, it doesn't matter what you start with. P could be $1, $1 million, or whatever. It doesn't matter what you start with. If you're 4.5% for 25 years, you will end up with triple what you started with. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.